Adam Rees on the universe and our comprehension of it. Barring the estimation blunders, there remains the genuine and energizing chance that we have misjudged the universe. A Nobel Prize winner cautions us that the James Webb telescope shows us proof that something odd is happening in the universe. If we trust the most recent estimations from the James Webb telescope, then our universe would have moved in such a peculiar manner that there is essentially no good reason for it. But what would that mean in substantial terms? Are we really vulnerable to the most recent advancements, or do we maybe already have a new explanation? Adam Rees is one of the leading cosmologists of recent times. Years ago, the Nobel Prize winner introduced notable work on the expansion of the universe and found disturbing errors in the estimations of the Hubble constant. These differences from prior estimations became known as the Hubble strain. Rees, alongside thousands of other researchers around the world, eagerly awaited the launch of the James Webb telescope. The new technology would finally provide confirmation of the true nature of the universe, answering questions such as, were Rees's estimations wrong, or were the older estimations wrong, finally bringing us clarity. Of course, it was also possible that the Hubble strain was a previously unexplained phenomenon, but no one wanted to face that reality at the time. The Webb telescope stunned researchers because the latest estimations confirmed the accuracy of every previous measurement, and hence, a pure estimation error could be ruled out. More and more, the differences in the measurements don't happen because our telescopes measure incorrectly. Hubble and Webb each made two estimations, once using Cepheids as standard candles and once using Type 1a supernovae. In this context, standard candles are estimation constants that researchers use to achieve accurate results when measuring the universe, using the absolute brightness of these phenomena. Both measurement techniques should show comparable results. What was measured was the expansion of the universe, or rather, the rate at which the universe is expanding and how it's speeding up or decelerating in the process. Minor measurement differences would have demonstrated a difference in the absolute brightness of the standard candle and would have been entirely reasonable. However, the difference is so precise that Adam Rees suspects the Hubble strain is guiding us toward other central misconceptions about the universe. Adam Rees has found an explanation. Did you know that Adam Rees is the father of dark energy? In 2011, Rees shared the Nobel Prize in Physics with Saul Perlmutter and Brian Schmidt. The three researchers were honored for their groundbreaking discovery that the universe is not only expanding, but doing so at an accelerating rate. This acknowledgement also stunned scientists because, according to current physics, the universe should actually be slowing down. Imagine how the Big Bang was an initial energy burst, and then the universe races off, forming matter and occupying an ever-expanding space. According to our current physics, it should eventually slow down. This thought that the universe will ultimately hit a wall, as it were, led to the Big Freeze hypothesis, in which the universe will end up in a sort of state of shock in the far-distant future when all energy is used up, all processes stop, and the universe freezes. But the measurements taken by Rees and his associates showed that the expansion of the universe isn't slowing down. It's speeding up. But how could that be? This nonsensical reality led to the introduction of the concept of dark energy, a force which no one has yet seen or measured, but is believed to be responsible for the strange, accelerated expansion of the universe. To confirm these speculations, the Hubble Space Telescope was used before the launch of the James Webb Telescope. Adam Rees works not only as a professor of astronomy at Johns Hopkins University but also at the Space Telescope Science Institute, which is responsible for the Hubble Space Telescope. The James Webb Telescope confirms Rees's hypothesis. Think for a second about your view of the universe. Do you also imagine a space in which there are objects that rotate, turn, are created and destroyed? Can you see that this space is getting bigger and bigger? This is a thought that might seem a little crazy to us, but it is a reality. The universe shows proof, on many levels, of an expansion of the entire space. So far, the only logical explanation for these effects is that the universe grows from a starting point. However, as already mentioned, the universe would then need to slow down at some point, or maybe it shouldn't expand faster and faster forever. This is where the James Webb Space Telescope and its exceptional mission become important. In 2 years of operation, NASA's newest telescope has already shown us many peculiarities that confirm Rees's hypothesis. These include galaxies that are so old that they shouldn't even exist. Additionally, so far, there has been no sign of a dark age or of genuine relics from the Big Bang. Thanks to Webb, we can see clusters of galaxies that are so massive and so large that they challenge the theory of an isotropic universe. This, along with the peculiarity of the Hubble strain, confirms the assumption that we simply didn't understand the universe correctly. So far, these new discoveries will possibly lead to fundamental changes in science. It isn't just Adam Rees who sees that the scientific understanding of the world and the universe is currently facing significant challenges. More and more scientists admit that more and more complex riddles in cosmology are forcing us to reconsider revolutionary changes in the universe. Who would have thought that a simple telescope could cause our entire cosmology to implode? Although the James Webb Space Telescope isn't just any instrument, it's the best telescope we humans have ever built. No one anticipated these observations. It's as though a completely different universe is suddenly appearing before the scientists' eyes than the one they thought they knew. There are signs that the universe is older than we believed, and that galaxies were formed more quickly and differently than previous speculations had predicted. We may indeed even have to get used to the idea that the universe is limitless. Perhaps we don't even come close to understanding how matter really appears. Webb also provides observations that stir doubts about the existence of dark matter. If dark matter doesn't really exist, another pillar of the old theories will have been lost. But how could we then explain the phenomena that led to the invention of this mysterious matter? It was researchers like Edwin Hubble and Fritz Zwicky who predicted that there must be an invisible type of matter. Only with the help of this type of matter could the identical rotational behavior of galaxies and some other phenomena be explained. There are other ways of explaining these phenomena without the presence of dark matter, but they aren't quite as logical. Webb also shows us that the assumption that the universe appears the same in all directions could be flawed. This effect of uniformity is what scientists call isotropy. If this isotropy is flawed, then the old cosmological model is shaken even further. In the early 2000s, Rees and other scientists introduced the concept of dark energy to explain the accelerated expansion of the universe. However, the existence of this type of energy is still uncertain, just like the existence of dark matter. Due to these new revelations, it's expected that the standard model of cosmology will soon be fundamentally updated. But where might this change eventually lead us? Now, these new perspectives astound us. Imagine we live in a universe where not a single physical constant is right. That would mean that Einstein's theory of the constant speed of light is false, that standard candles can never produce the same results, and that physics changes locally and even over time within our universe. Such thoughts emerged after the latest measurement results of the JWST, and the most recent theories go much further. In addition to the possibility that our physics can describe only a portion or a oppo of the universe, there are theories that see intelligent forces in dark matter or dark energy. This would imply that our universe has something like a soul or its own intelligence, which could, in turn, explain who created the universe and why. We would still be far from having real answers to our questions, even after such understanding affirmed, we would essentially know that there is such an incredible concept as a creator. Insightfully, up to this point, we have always investigated the light and into matter to understand the universe. However, now it is becoming obvious that the designs we are searching for lie in the mysterious darkness of the universe. Of all places anyway, this hasn't actually been proven either, and we must continue to see what is unfolding before our eyes. What measurement results we get from the latest Webb observations and what that means for our science. We humans have begun to explore our environment and, eventually, the universe because we wanted answers to the questions of who or what made it and why it exists. We may now be at a defining moment that changes our old perspective so decisively that it feels like a revolution in knowledge and science. Less troubling hypotheses simply state that our universe is much older or that it might have no beginning and no end. Be that as it may, where do the signs of expansion come from? Here too, there are exciting new ideas that suggest that our universe is subject to territorial flows. You can imagine it as something like a drifting bubble formation that contracts or expands regionally, reaching different rates of acceleration and development. There was never a Big Bang, it makes sense. It is to be expected that there has been no real proof for the Big Bang either. Just the fact that for a time, all the theories fit together so well and seem to confirm the idea of a starting point some 13.8 billion years ago. However, we have never seen any genuine proof for it. If we take another look at quantum and particle physics, we find further evidence that something is off with our old perspective. From the quantum world, we know that our universe should be much more mutable and adaptable than previously believed. And you might be surprised to discover that not a single piece of evidence for the true physical existence of matter has yet been found in particle physics either. Our cosmology, however, is based on the observation of material phenomena, and from the behavior of matter, scientists have drawn conclusions about types of energy and forces. This might have been a conspicuous mistake.